Lesson number 5 is determining angles and sides in right triangles. So basically lesson number 5 combines lesson 4 and 3 and 4 together. So you're given a triangle and basically you're told to solve for a missing side length of the triangle and you need to figure out how to do it. That's really what lesson 5 does. So if we look at class example number 1A, I'm asked to find an angle measurement. If I'm asked to find an angle measurement, I have to be looking at SOHCAHTOA. There's no other way to solve it without using SOHCAHTOA. So if I look at my angle in question, how do I name these two sides? So I have an adjacent and I have an opposite. So I would use tan. Tan of angle X is the opposite over the adjacent. So then to calculate angle X, it would be the tan inverse. And we can type that exactly how we see it into the calculator. Tan inverse 12.7 divided by 5.2 equals?
67.7.
So to the nearest whole number? 68 degrees.
Thank you.
I get started here. So how would I solve for X in B? What did you use to solve for X in B, Colin? So tan what? Tan what?
I didn't write down how it set up.
But if you were going to write it down, what would you write down?
Tan 24.
Equals? What's opposite over adjacent? So it would be opposite, which is over.
68.
And then how do I get X by itself?
Multiply tan 24 by 6.
Okay. And then what do I get to the nearest whole number? 30? So that's what I would expect to see on an assignment or on a test when it asks you to determine or calculate the measure. It means show me your work. Show me your calculations. How would I solve for X and C? Kirsten, what did you do?
I went sine 69, and then 126 on top, and X on bottom.
Okay, so then how do I solve for X?
You divide 126 by 7.
Okay, because I showed you the other day, we basically are switching those two around. So what do I get?
135.
How do I know if 135 is an appropriate answer? It's the hypotenuse, so it has to be longer than 126. Okay? And this 30 degrees, how could I know it would be appropriate? Well, this angle 24 has to be smaller than this one because 24 and the blank angle have to add up to 90. So 68 has to be bigger than this side. Because I can't always trust the way the triangles are drawn because sometimes my math teacher doesn't draw them to scale. Say. So how would I solve for angle X and D? Okay. You use cosine. So cosine X equals what?
4.0.
And then to find angle X, I would have to do the...
Taylor.
Are you speaking, Taylor?
Taylor, keep going.
What do you get for an answer?
6 degrees.
Thank you. Does it matter if I don't put the degree symbol on it?
Probably should.
It's not a probably.
You
I have
probably
to.
should.
Because it's an angle, so I need to have that degree symbol in there. Okay? Class example number 2. A telephone pole is 11 meters high and it's supported by a wire 13 meters long fixed to the top of the pole and to the ground. Calculate to the nearest degree the angle between the wire and the ground and calculate the distance to the nearest tenth of a meter between the point where the wire is fixed to the ground and the foot of the pole. So before I start doing this question, what should I consider doing?
Draw a diagram.
I should probably sketch this out. There we go. And I can assume that the telephone pole would make a right angle with the ground.
No, it's like put it in crooked.
Pretty certain you wouldn't put it in crooked, the
Oh,
whole
my
idea.
God.
Yeah. The idea would be to try to put it straight. So the telephone pole is 11 meters. That's my vertical leg. The wire from the top of the pole to the ground, that becomes my 13. So I want to know the angle between the wire and the ground. That becomes my angle. So we can call it x. So how would I calculate angle x? What would I use? Sine. So sine of angle x equals the opposite over the hypotenuse. So then angle x would be the sine inverse. Thank you. Okay. And then if I calculate the distance from the wire to the foot of the pole, so we'll call that y. How would I use Pythagoras' theorem to solve that?
C squared minus B squared equals 8.
Okay, so then
13 squared minus 11 squared.
so what is 13 squared minus 11 squared?
48. The square root of 48 is 6.92.
So to the nearest tenth of a meter would be
6.9.
okay. And what if I had to use trig? So I now have an angle. I have this being my 58. How can I use that? In relation to the 58 degrees, what do I call side y? The adjacent. So I'm trying to find the adjacent, and I'm given both the opposite and the hypotenuse. So which trig function could I use? Cos. So I could use cos because that would be adjacent over hypotenuse. What else could I use? I could use tan, opposite over adjacent. So I could use either one. It doesn't matter. If I used cos, the cos 58 is the adjacent over the hypotenuse. If I use tan, it would be tan 58 equals 11 over the adjacent. So for the cos one, y would equal 13 times cos 58. And if I use tan, y would equal 11 divided by tan 58. So I want this table to do the cos one along with Colin and Raylan, and you 5 will do the tan one and tell me what answer you get. So from Jonathan this way, I want you to do the 11 divided by tan 58, and you guys do the 13 cos 58 and tell me what you get.
To the nearest 10.
To the nearest 10.
Yep.
What'd you get, Delana?
6.9 meters.
Which I should get, right?
Yeah.
Okay. So we're going to push through, we're going to finish this up because the next 2 examples are not much different. Solving a right triangle. If you were asked to solve a right triangle, what it means is you need to find all the missing information. Triangles have 3 angles. if you're given 2 angles, you need to find the third angle. If you're given 2 sides, you need to find the missing side. You need to find all the missing pieces. That's what it means to solve a right triangle. When you are solving a right triangle, try to use the information that's given. Don't use the data that you find unless you're going to keep those 5 or 6 decimal places, unless you're going to try to keep that answer as true and accurate as possible. That's why it's always easier to go back to what you have, because those are exact measurements. So if I look at this triangle ABC, I have angle A, I have angle B. How do I find angle C?
You have 2 sides or 2 angles, so don't you add them together and minus 1?
Okay, so I can subtract them from 180. And what do I get? Now, because these are given to me as exact values, I could use the 53 degrees as part of my calculations because it has not been rounded.
Also,
But if you, pardon?
Also, if it's a right triangle, you can just subtract the 180.
Yeah, because this already takes up half of the 180, so I could just subtract the 37 from 90. So now I need to find my 2 side lengths. We can call them x and y. So let's start with side length x. How would I find x? I have an angle. What do I call this side? And what do I call this side?
You could either use the adjacent, it could be either the adjacent or the opposite. It matters which angle you use.
So if I'm using angle 37,
Then it'd be the adjacent, which means that you use cosine.
okay, so cos of my 37-degree angle would be adjacent over hypotenuse, which means I would multiply. And I round this to the nearest whole number. If I had used sine, it would have been sine 53 equals x over 33, and I would still get the same answer. So now I want you to take a moment, and I want you to calculate side length y. Oh, the only other thing that I could do is I could replace x with the AB, because AB is the labeled side length.
Yeah.
So now I want you to find out what side length y would be. So in calculating side length BC, if I'm looking at my 37 degrees, it becomes sine because it's opposite over hypotenuse. If I wanted to use the 53 degrees, it would then be cos 53 equals y over 33. Okay? When I'm going back through and I'm checking this, so I said this was 26 and this was 20. The smaller angle is opposite the smaller side, so that can help me with determining whether or not I'm close. If I solve triangle DEF, means I need to determine this angle, I need to know this angle, and I need to know the hypotenuse. So what do I start off with, or what could you start off with?
Pythagoras theorem or find h.
Okay, so find h for me. Okay, so then with Pythagoras theorem, 5.3 squared plus 4.9 squared, square root of 52.1 equals 7.2. So which angle do you want to find, D or F? Pick one. F. F. Okay? So remember what I said, use the measurements you were given. So in comparison to F, what do we call these 2 sides?
Adjacent and opposite.
Which one's adjacent?
The 4.9.
So what trig function do I compare opposite and adjacent?
Oh,
Tan. So use tan to find angle F. So what was angle F? 47? Okay, how do I find angle D? And what do I get? So to find angle D, I don't actually have to go through and do another trig function. I have